Welcome to this explainer. We look at these machines all day. Maybe it's a metal box sitting beneath your desk, or that sleek laptop right in front of you. But have you ever actually stopped to wonder what exactly is happening inside? Today, we're going to break down the absolutely incredible teamwork happening inside your computer. We are taking what usually sounds like super dry, complex technical specs and turning it into a fascinating journey through the anatomy of a machine. Seriously, think of it just like a biological system where every single part has a highly specific, totally vital role to play.
Here is our agenda for today. First, the foundation and heart. Second, the brain of the machine. Third, memory versus permanent storage. And fourth, visuals, cooling, and connectivity. Section 1. The foundation and heart. Building the basic anatomy of the computer. Okay, before we get to the really flashy processing power, we've got to start with the skeleton, the case. At its core, it's just a plastic or metal box that houses everything. They generally come in mini, mid, and full tower formats. But listen, here is the biggest mistake people make when building a computer. They choose the case first. Always, always size your other components before picking the case. You literally have to know how big the organs are before you buy the rib cage so everything actually fits. Now, having a sweet-looking box full of expensive parts means absolutely zero if it doesn't have energy. Enter the power supply. Just as the name suggests, this vital component takes electricity straight from your wall outlet and funnels it directly into the computer. It's the only way you can actually use the thing. The absolute key takeaway here is capacity. This power supply must be beefy enough to handle the combined electrical draw of all your other components. And that brilliantly brings us to our first major anatomy metaphor. Meet the motherboard. It's this wide, flat circuit board, and you can truly consider it the heart of the computer. Why? Well, because every single other component gets connected right here. Its entire job is to pump data back and forth, making the different parts communicate with each other. It's kind of fascinating because compared to some of the other parts we'll look at, it's relatively cheap, but you could definitely argue it's the most important component in the entire box. Section 2. The brain of the machine. Meet the central commander. So, meet the CPU, the central processing unit, or simply the processor. If the motherboard is the heart, the CPU is, without a doubt, the absolute brain of the computer. It possesses this incredible power to solve insanely complex mathematical operations and read through massive lists of data in the literal blink of an eye. Whenever you click to launch a program, it's the CPU that's stepping up to run the show. The crucial point to remember is this. Basically, everything that happens in a computer goes through the CPU at some point. However, it does have a quirk. The CPU itself usually has very low data storage. Think of it like a genius with a photographic memory for problem solving, but terrible long-term memory. It knows how to process information perfectly, but it just can't hold on to much of it at one time, which perfectly sets the stage for our next big concept. Section 3. Memory versus permanent storage. The bottleneck and the solution. Now we run into some dramatic tension. This brilliant brain needs massive amounts of data to do its job, right? But where does it get it? Well, we start with the hard drive. This is the vault. It's where all of your data is permanently stored. You know when your computer gives you that super annoying pop-up saying you're running low on space? Yeah, that means your hard drive is almost full. Now, hard drives are fantastic at storing a huge amount of data. But there's a big catch. Most traditional hard drives are made up of physical, slow-spinning disks, and they share their data out through a really small wire. That makes them incredibly slow to access. And this reveals a massive,
System-breaking bottleneck. Think about it. If the hard drive is so big and holds literally all our files, why can't that blazing fast CPU just talk to it directly all the time? Well, the answer is speed. The hard drive simply is not fast enough to feed the needed information to the CPU on demand. If the CPU had to wait for those slow spinning disks every single time it needed a number, your computer would literally crawl to a halt. So the hero stepping in to solve this exact problem is RAM. While the hard drive has massive space with slow spinning disks connected by a tiny wire, RAM operates completely differently. RAM has much less space available, but it offers lightning-fast access to information. Instead of a small wire, it's connected through a long, thin stick, allowing it to instantly communicate with the CPU. But remember, RAM is strictly a short-term memory system. It cannot permanently store your data. The second you turn off your computer, boom, all the data on the RAM gets completely wiped. Let's look at a real-world application that brilliantly illustrates this. Have you ever wondered what is actually happening when you're staring at a video game loading screen? Well, the CPU knows it needs a ton of data for the level you're about to play. So during that loading screen, the CPU is painstakingly taking the needed data from the slow hard drive and temporarily placing it into the ultra-fast RAM. It does this so that once the game actually starts, the CPU can access everything it needs instantly without waiting. You are literally waiting for data to be moved from the slow vault to the fast desk. Oh, and just a quick note to update our anatomy chart for modern machines. A lot of systems today upgrade the traditional hard drive to a solid-state drive, or SSD. An SSD achieves the exact same goal, permanent data storage, but it uses much newer technology. Because it ditches those physical spinning disks altogether, it is far faster and way more durable. The trade-off? SSDs are usually a bit more expensive, which is why some computers use a mix of both, or just rely completely on one standalone SSD. Section 4. Visuals, Cooling, and Connectivity. The heavy lifters. All right, so we've got a working brain, a pulsing heart, and a brilliant memory system. Now think about this idea. A graphics card is basically an entire standalone computer dedicated only to showing the right things on your screen. That really emphasizes just how incredibly difficult a computer's job actually is. Think about the massive amount of complex calculations required just to create a 3D world in a game. But the truly difficult part comes when it's time to actually render those worlds on your screen, in real time. And that is exactly what the graphics card does. It acts as a totally dedicated workhorse, deciding exactly which of the millions of tiny pixels on your monitor need to light up and in what exact color, frame by frame. Now, it is worth noting that some CPUs actually come with an integrated graphics card built right in, but those are almost always much less powerful than having a normal dedicated graphics card doing the heavy lifting. But hey, all this incredible processing power comes with a really dangerous side effect: heat. Because the CPU and the graphics card work so intensely hard, they generate a massive amount of heat. In fact, if it weren't for a cooling system, these components would literally fry themselves and take everything else in the case down with them. To keep things safe and actually operational, computers utilize cooling systems. You generally have the choice between option A, air cooling, which uses fans, or option B, liquid cooling, which uses a fluid system to draw the heat away. Each has its own pros and cons, but having one of them is absolutely non-negotiable. Finally, to connect our little standalone universe to the rest of the world, we need communication. If your computer supports Wi-Fi, it features a wireless card. This component drops right into the system and gives your machine access to the internet,
entirely freeing you from needing physical Ethernet cables. So, as we wrap up this explainer, I really want to leave you with this thought. We interact with these machines every single day, completely oblivious to the absolute symphony of hardware humming underneath. The next time you press that power button, think about it. Think about the heart connecting the pieces, the brain crunching the numbers, the RAM desperately juggling the data, and the graphics card pointing the screen. If all of this magic is hiding inside just one plastic box on your desk, what other hidden symphonies are playing out in the devices you use every single day? Thanks so much for exploring this with me. Keep learning, and I'll catch you next time.